Let's finish with a few examples of the type of questions that are pretty common when dealing with infinite geometric series. So it says to determine whether the infinite series converges, and if it does, find its sum. And recall, what makes each of these infinite series is that you are summing up an infinite number of terms. In other words, you're not stopping the adding process. Okay, and what we're interested in is, does that, when you start looking at that sum, does it start to approach a number? That's what it means to converge. So let's look at A. I'm going to rewrite A down here. So we've got, in sigma notation, this series. Now notice these are all geometric. All right, and what I'd like, what's good to do, just as a good habit, is to write out the first few terms. So when I plug in 1 for k, this becomes 10 times 1/2 to the 0, which is just 10. Plus, when I plug in 2, I get 10 times 1/2 to the 2 minus 1 is 1, so that's 5. Right? Another way to think of it at this point is 2 is our r value is just 1/2, so the next one's going to be 1/2, ... So the question is this going to converge or diverge? Well, it's very easy actually to know, because it's a geometric, and our r value, or the absolute value of our r value, which is 1/2, is less than 1, and what we've seen is if that's the case, it's going to converge. So that's the first part of this question. The second part, notice says if it does, find the sum. So finding the sum amounts to us actually applying the formula, which is that the sum is equal to the first term, which is a 10, divided by 1 minus my r, which is 1 minus 1/2. So that's 10 divided by 1 minus 1/2 is 1/2, which is 10 times 2 over 1, which is 20. Let's look at B. B is the series 3 times 5/2 to the k minus 1. Alright, so once you start getting familiar with these, you can actually answer the question without expanding it. But again, I do like to just get in the habit of doing it, also because it reinforces your understanding of sigma notation. So when you plug in 1, the first number is 3 times 5/2 to the 0, which is 3 times 1, which is 3. Plus, you plug in a 2, and it's 3 times 5/2 to the 1, so that's 15/2, which you notice is 7.5. So we could even stop here. The question is this going to converge or diverge? And the answer is it's clearly going to diverge, because we're multiplying by a number that's bigger than 1, whose absolute value is bigger than 1, which means that every number we add is bigger than the last one, whereas up here it was smaller. So the answer is diverge. And notice, if that's the case, we don't apply the formula, right? We can give our reason why it diverges, which is important. It diverges because the absolute value of 5/2 is bigger than 1. But we don't have to apply the formula. But of course we don't apply the formula because it doesn't converge. So we're not going to state what the sum is, because there is no sum if it diverges. And let's finish with C. C is k goes from 1 to infinity of 1/5 times 3/5 to the k. Now this is the reason I want you to write out the first few terms, or I think it's important, is because of this. Students get these problems and they say, okay, I get it. The first term is just going to be whatever this number is here, right? I mean, the first term was a 10, and a 10 is what's in front of my r there. And in here, the first term was a 3. So I get it. I can figure out what my first term is pretty easily. I mean, my r is right here. Now that is true. The r is going to be right there. But it is not true in this case that my first term is 1/5, right? It might seem like it is, but that's only if this exponent is to the k minus 1, right? If we're starting by plugging in 1. So I'm babbling here, but to make a long story short, just plug in your first, the first value here for k to figure out what the first term is. Don't look for shortcuts. So when you plug in 1, you get 1/5 times 3/5 to the 1, which is 3 over 25. Okay, when you plug in 2, you get 1/5 times 3/5 squared. Let's just do this up here. 3/5 squared is equal to 9/5. And we're timesing that times that fifth in front. So it's 9 out of 25. Okay, now etc. So the question is, this converge or diverge? And because our R value, the absolute value of 3/5 is less than 1, simple test, that means it converges. And therefore the sum is our first term, which this case is 3 over 25. I'm running out of space here. I'm going to shrink it up a little bit. So the sum is equal to the first term, which is 3 over 25, divided by 1 minus my R value, which is 3/5. So that's 3 over 25 divided by 1 minus 3/5 is 2/5, right? Because 1 is 5/5. And that's the same as multiplying times the reciprocal. It's 5/2 here. And 5 goes into 5 once and into 25 5 times. So we've got 3 times 1 divided by 5 times 2. So it converges to 3/10. 3/10. All right, so there's some examples of the type of problems you come across when dealing with infinite geometric series. Just don't forget that the test is very simple, right? The test is very simple, and that if it diverges, you don't apply the formula because the formula clearly only applies if it's a convergent series.